Thanks, Mike. I appreciate that talk. Now, the next two talks will be on some of those restoration techniques or those methods that can get us to more bright spots. So our next speaker is Herve Piegay. He's with the French National Center for Scientific Research. He's a research director and has worked on just about every river in Europe that I've heard of. And currently is directing a very large restoration science program on the Rhone River, France's largest river, in which ecologists, geomorphologists, social scientists, managers are working together to preserve some of the best habitat available on a very large, very impacted multi-use river. It's a very exciting program if you're not familiar with it. Truly interdisciplinary, and he will make a plug for a conference that's going to be next June in Lyon, France, that will feature a lot of the players and participants and scientists on this. So, without any further delay, I'll introduce Herve Piegay.
Good morning. I'm very pleased to be here, and I thank you very much, the organizer, for inviting me.
1 minute.
I like to come in California. I have many friends, and you have rivers which are very close to the one we are studying in Lyon, but sometimes less impacted. And it's really interesting in terms of process-based understanding to compare the different regions and the different river systems. So today I'm going to speak about riparian characterization from remote sensing in a multi-scale perspectives. So the objective or the mission that John asked me with the organizer is to give you a few examples of what it is done in France in this domain, in the Rhone Basin. And I will introduce two aspects. The first one is the idea of combining computed or field data with archives and with remote sensing image, which are archived. And this is something which is a bit different. I mean, when I was working on river 10 years ago, most of the knowledge were coming from the field. And now, most of the time, we combine field data with remote sensing data. And it's a completely change in the view we are approaching the problem. And the other aspect is now we are producing our own image because we have sensors and platforms we can handle by ourselves. So it's done in labs, but it's more and more done also by private consultants. So we are producing our own remote sensing data. And in 2012, we published a book about fluvial remote sensing, and there is chapters about riparian vegetation, which is open to inform decision makers and consultants that here we have more and more very important information. So I will go to the example, and first with archive data, and we use a lot information provided by the French National Geographical Institute with orthophotos since the 50s, but also with LiDAR imagery, with LiDAR sensor, which are acquired over long channel reach. When I say long, it's more than 100 to 500 kilometers long, but also at a regional scale. Another thing which is interesting is, as Mike said before, we have more and more technology which are available. I have spoken about the platforms, but it's not only a question of platforms, it's also a question of software, which has been recently developed. Now we have the possibility, quite easily, with a structure from motion approach, to have photogrammetric information at different scale in space and time. We have also the OBIAS approach, the object-based image analysis, which is also very useful to classify different characteristics of our landscapes with very high-resolution imagery. And we are developing also different strategies to be able to characterize quite quickly our environment at a network scale. And we have developed a fluvial corridor toolbox, for example, which is very useful to classify river reaches over networks according to a set of objectives. So the first point, I will take the example introduced by John just before about the Rhone River. It's a very modified river. You have an idea here of the infrastructure which has been built at the beginning of the 20th century. And so you see it's done over more than 300 kilometers long between Lyon and the Mediterranean Sea. And we are now in the process of thinking about what we should do with this infrastructure. Should we remove them? Like you are removing riprap protection. Now this system are mainly forested. So do we have nice forest here? What are the characteristics of this forest? And this is one of the issues to better understand what is the value of this forest, ecologically speaking, but also socially speaking, to see what kind of patches we may remove to promote bank erosion and the cycle that Mike showed before. And so we are using orthophotos to determine the age of the forest you have here, but we are also using LiDAR to have an idea of the elevation and the connectivity, the flooding frequency of these features. And in the same time, we are going to the field to have an idea of the environmental condition we have in the different areas, but also to have an idea of the composition of this alluvial forest. So this is the kind of figures we can get. For example, here you have the mean diameter of per plot of the trees we are observed, and this is the relative surface elevation. This is coming from the field. This is coming from the LiDAR and the remote sensing approach. If you look at this DCA, this factorial map, all the points are a station, and they are described by the vegetation composition. And what you see here is they are well distributed over this axis according to the relative elevation and the submersion frequency. So it's really, the composition is fundamentally linked to the connectivity. But just to show you, we have here a mixture of field data and remote sensing information. And you have the same thing here. You see, this is the same pattern. You see the stations, the plots. But here you have the surface age, and you see it evolved a little differently from the first two ones. The surface age is provided by the combination of the orthophotos we have rectified and combined from the 40s until to now. It's another kind of information. So another example, but which goes in the same direction than the one I showed before, on a fairly braided river. You have here the LiDAR information providing us the topography. You have here an information which is a canopy height model. It gives us the height of the different vegetation patches, and in the same times, with the density of points, it gives us also the density of individuals. Here you have the age of the floodplain, and this is the physiognomic vegetation patches. And if you look at this analysis, on the first factorial axis, you see that you have the successional stages showed by Mike presently, with the pioneer species up to the mature vegetation units. And this has been done by photo interpretation, but now we have the possibility to do it from remote sensing information. And here, you know, this organization, which is related to successional stage, is provided by the height, the cover, and the age. So the information I collected from the imagery, the LiDAR, and the combination of aerial photos. We can go a bit also further than that, and notably in terms of targeting action, in terms of planning action, because we can imagine to do that at a regional scale. So this is Belgium. I work with colleagues from Jean Blou in Belgium. And the gray area, this is the Wallonie region, which is a French-speaking Belgian part. And here there is an hydrographic network quite well developed. There is eco-region, you can see that here. And they have also a regional LiDAR covering the whole region with an elevation precision of roughly 10 centimeters. And in XY, a spatial precision of roughly a sub-meters. So we use this information to characterize the riparian vegetation. So we use a fluvial corridor toolbox to create some segments within which we are going to collect the information. And we looked at overhanging. We look at the continuity of the riparian buffer along the channel network. We did some validation from field work. We combined, again, field effort with remote sensing. And from this, we were able to provide, for example, maps like this, where you can get the longitudinal continuity of riparian forest at a national or a regional scale. I mean, it's really exciting. Now we can think at a national level. It's incredible. I mean, 20 years ago, I did not imagine I could do that. Okay, so if you look at this map, you see that when it's red, there is almost no riparian buffer. And here it's upland. It's completely natural. It's an area with spit. But you see here we are in an intensive agricultural area. And we must see where we have a lake of riparian forest. In the middle, we have an agricultural land where the riparian forest, in average, is still well established. What it is truly incredible is now we can go cross over the scale. I mean, here I show you a map which at a national base. But the resolution is so great that I can zoom at a local scale and use it to target action at a national scale, to plan action, but also to act at a local level. Just to show you this. This is a detail scale, what we call the management forestry unit, a few hundred meters of rivers. And we have this information for each of the management unit in terms of longitudinal continuity, mean height, overhanging characters. And also it's becoming crazy, I would say. I would have said exciting, but it's not a good word, crazy. You see, because we can also explore this temporally. We can have now LiDAR one level, one time, but 2 times, sometimes 3 times. And here we can monitor automatically what's going on in terms of forest clear cutting, or also in terms of urban riparian forest. You see you have a nice one here in 2009, and in 2012 it has completely disappeared. So it was just illustration for the debate, for the discussion. Now the second point is our own remote sensing acquisition. So at the beginning, we were among the first to use drone in the 2000s, in 2005, for example. So this is the dinosaur of the drone. But also we use this one for a while, and now we have an octocopter. But we also use this kind of platform just because sometimes we have questions at a local level, but we can also have questions over several tens of kilometers of river. And here, if you use that, it will be difficult. It will take a while. Okay, so you are familiar now with this kind of image where the resolution, is a few centimeters. So we can see nicely the gravel augmentation. We can see nicely the organization of the vegetation patches. And we can also, if you like gravel bed rivers, we can also see the gravel, which is incredible. Okay, also what we see is we have a very high multi-temporal resolution. We can get many photos in one day. We can have a few photos of the same area. We can approach seasonal aspects, interannual changes. We have a very high spatial resolution. And more, we have also a spectral resolution, which is better and better. Because on the local platform, for example, we can install some LiDAR, and we can get LiDAR information from drone at a local scale. Also, we have thermal imagery to look at the temperature of the river. And more, some sensor, hyperspectral sensor, are also installed on this platform. So a few examples here about temperature. This is the river, so it's a small Sacramento. If you know the Sacramento upstream Colusa with very shifting system, it's exactly the same but smaller. We are looking at the temperature over a reach of 40 kilometers. It's shorter, it's smaller also in length. Here you have the LiDAR providing us the vegetation. From this, we can get the variation of the Riparian shading and create a shading factor to look at the solar variation from 8 o'clock in the morning to 22 in the evening. You see that the sun is almost present in the middle of the channel. It's a 70 meters wide channel. And along the two banks, it's more shady over the year. And we put this information into a model in which we are considering the interaction between atmosphere and the water. We are also considering the hydraulic properties and the groundwater inputs. And so what we see here, we have two examples. One in 2010, one in 2011, and in blue this is so in gray this is without groundwater input and without cover of riparian vegetation. In green it's with riparian vegetation, and in blue it's with vegetation and with ground cover. With groundwater input. And if you look at this example, you see that the contribution, even on this large river, of the riparian cover is quite significant. And combining groundwater and vegetation cover, we can gain 1 degree. And 1 degree, when we are in a system which is sensitive to temperature increase, it can make the difference. So, and it's a large river. Imagine with a river with a lower slope, low velocity and very narrow. Here the impact is tremendous. So this is a critical point on which we can go further. Another example is a riparian forest of the Drôme River. It's a braided river. It has been published in Eco-Hydrology recently. We use drone imagery yearly. We relate this evidently with floods, and we got image like this. So you see that we got a flood in 2005. In 2006, no vegetation encroached. Explosion of vegetation occurred in 2007. And if we look at this longitudinally, we have a very wide braided river here. Encroachment is quite low. Here, it's narrower. Vegetation develop very tremendously. So the local conditions are very important to understand the recruitment and the propagation of seeds. And once vegetation is established, it resets the possibility to colonize the river. The colonization is truly a very complex pattern we still have to understand. And the drone imagery's yearly survey is a way to explore this. Also, not only the question of recruitment, but also the question of growth. When they are established, how fast they are growing. And you see here, this is a relative surface expansion, the growth of the riparian vegetation, which are related to the mean growing season temperature. They have access to water, but when the growing season is quite hot, the growing is more important. Also, we are looking at using drone. We are looking at a question about forest species, health condition, and potentially invasive species. And here we worked with drone, with object-based image analysis I introduced previously. Many surveys done at different dates to learn what are the best conditions for detecting species, for detecting health characters, or for detecting invasive species. And here you have an example, for example, about species approach in one of the two papers I introduced before. So you see we have different size of our object, and according to this size, there is different variables which are useful. So if it's very detailed, pixel by pixel, or very small obvious object, then the spectral information is the most important. If we go to very coarse patches, or even at the scale of the tree crown, here the textual information can be meaningful to detect what we are interested in terms of species or vegetation characters. And this is the other paper is showing what are the critical variables to be able to detect some of the invasive species. So the conclusion is, as you have understood, perhaps I am very excited by this period. It's crazy. It's just the beginning, or 10 years ago it was the beginning, just the emergence, and now we are in, and new things occur. A lot can be provided from the air, a new era in data collection. Also, we have less used satellites, but more and more they are interested in terms of temporal resolution, and the range in the spectral resolution is also higher and higher. So this is truly exciting. Pleiades, Sentinel-2, and others. The archives, we have a lot of still to do. I spoke about the temporal resolution to explore vegetation succession at the seasonal or at a yearly scale. Also, the question of restoration and the stakes we have in terms of monitoring the success, monitoring restoration. And I did not speak about groundwater imagery because it's also an issue, but I have not time to introduce this. But the video is also something which is critical. And actually, you know, in the Sacramento with John Stella, we are exploring some of the sensors we can use in the future. Thank you very much. Just to draw your attention to a conference John said before, in June 2018, we organized a conference, 500 people in English, half river manager, half scientists. It's really alive here. We are speaking about riparian vegetation in the same context. Here we will speak about riparian vegetation, rivers, and all the stakes associated with that. I have cards. There is others there. Thank you.